Welcome, welcome. My name is William Cho. I'm responsible for a large part of the HPE networking product development organization. I'm also joined here by Vincent Gilles. There's still lots of people coming in, but let's go get started to keep everyone on time. So today we're going to talk about secure AI native networking, in particular around CX switching and how we drive self-driving networks. So we will be talking a little bit about futures, and there's a bit of a disclaimer here. Things could change, but this is just a formality, if you will. But more importantly, we have a very rich agenda for you. I'm going to kick things off with a bit of an overview, introduction, and then Vincent is actually really going to give you the richness of the content. We'll start off about how we use ASICs and how they matter as it relates to security. We'll go through a bit more detail around how we leverage the CX portfolio and really to help make the network admin's life much more efficient, more productive, more secure. And then foundationally, what did we build into the CX portfolio as it relates to telemetry so that you can get better insights into your network, all in that context of self-driving networks, in the spirit of the self-configuration, the self-optimizing, the self-healing environment. And then we're going to wrap things up with a bit of a case study and demo. Okay? All right, without further ado, let's go into this. So as you think about the security-first AI native network, this is a bit of a broad framework for which we're building on, some of which is reality today, and some of which we're going to continue to build over the next couple of years. And so as you can see here, as a foundation, this is our framework across all of our infrastructures, whether it be APs, physical firewalls, switches, and our routers. And it's bringing this all together in the spirit of having the great telemetry, high resolution visibility into the physical network, a comprehensive portfolio, and then having AI ops tools and technology to really give you that insights into what's happening, maybe even a predictive or proactive capability into your environment. And all of this is accessible by way of industry standard APIs. And so with that, we have a lot of customers that have built out with CX switching, but across all the different market use cases, market verticals. You can see them here just as a small sampling of customers around the globe that have delivered on the self-driving capabilities. And with that, we continue to innovate and build on our portfolio. So CX is actually a bit of my baby. I've been with the company now for 7+ years. Vincent, I think actually twice as long, yeah? But you can see here, CX, we started this journey about 2019, 2020. We built out a very rich portfolio of products, really for every use case you could imagine, from the data center to the core aggregation, all the way out to the user and device access layer, across, again, any number of different market use cases. But we're not done. We continue to innovate, continue to bring out much more platforms. In fact, I just had a session earlier with a retailer, and they were asking about the CX-10000. Is there more happening? In fact, we just announced the CX-10040 just a few months ago. It's just now starting to ship. This is, let's say, a big brother to the CX-10000 that we introduced about 3-4 years ago. More optimized for 100 gig, 400 gig spine connects for the very high performance compute environment, with all the stateful services that you've come to experience with the CX-10000, but with a scale-up, scale-out capability with 6 DPUs, AMD DPUs integrated into that platform, providing you line rate, high-resolution visibility. Second, we're building on top of the AOS 5400 that has been out there for 7, 8, maybe even 10 years now. We just introduced the CX-based 5420. So if this looks familiar, it is, because it is a modular switch that has 6 half-width line cards, right? And so this is purpose-built for both the access layer as well as the core ag having the continuity of CX as an operating system and all the richness of capabilities that you would come to expect. Yeah. And then lastly here, we've just introduced 4 more 6300 configurations, 2 very simple 24-port, 48-port SFP configurations, adding to the 6300 portfolio today, as well as 2 smart rate, let's say hybrid configuration that has both smart rate as well as 1 gig capabilities, as well as 8 ports of SFP+. So this comes in very handy in some cases, let's say a retail environment or maybe even hospitality where you have mixed use. You can complement them together with our existing 6300 stackable within all of the existing portfolio today. All right. And then the last slide I wanted to touch on here is really around the richness of software. The CX software train is very live and well. In fact, we release well over 100 features every year. We have 2 major releases, 10.16 earlier this year, and as Vincent just reminded me, 10.17 was just made available in a matter of days. And so you can see here 3 major buckets around security, telemetry, networking, and sustainability and management. I'm not going to go through every single feature here, but this is just a sampling of key innovations that we bring about in all the different facets of the CX software stack. So here, TLS threat detection, simply the ability to look at encrypted traffic, identifying anomalies, behavioral capabilities, so that we can provide you insights into what might be coming onto the network, again, whether it be from users or devices. Radius proxy support, being able to have a Radius intermediary with the CX switch, and then being able to leverage OpenConfig, a very standard-based data model, and GNMI for all the telemetry capabilities that you want to bring about into your environment. And this is something that we've actually been expressing in CX for well over a year, maybe 18 months now. We had historically implemented that with our central integration, but now you have the OpenConfig data models available for integration as a vendor-neutral capability across third-party management platforms. And then when you go onto the networking bucket, there's another key capabilities. VSF, obviously, we've had for many years, but now bringing that capability into the 6300 product family, but also bringing VSF down into the 6100 as well as our 4100 capability. So bringing that stacking capability throughout the portfolio. And then EVPN Type 6 routing capabilities, so extending the EVPN over VXLAN capabilities throughout the architecture. And then lastly, as you look at sustainability and management, there's a number of key capabilities, bringing about hibernation capabilities into the portfolio. Containerization is something that we've been working on for some time, building out the guardrails so that you don't overrun the memory and the CPU, but ultimately allowing for third-party applications to be integrated into the Docker infrastructure and ensuring that we have, again, those guardrails. And then a number of enhancements as it relates to precision timing and audio-video bridging. And so this has actually been a focus area for us. I'm curious if anyone familiar with PTP and AVB already? Some small amount of the audiences. But there, it's really about converging what historically, as you think about broadcast technology and purpose-built AVB technology into the Ethernet world, leveraging timing and precision timing, in some cases, very high precision timing that we integrate into our switches with high fidelity clocks so that you can take advantage of, again, broadcast use cases into your Ethernet fabric. That's all I had. So we're going to continue to bring about innovations and richness. With that, I do want to hand it over to Vincent, who's going to go through it in much more detail. Thank you.
Thank you very much, William, for this great introduction. Hello, everyone. Welcome. So as William explained you the richness of the portfolio, let's dive a little bit more into the hardware. and how the ASICs really matter for the security. So as a network admin, I want to know exactly what happened on my network, web-based application, all on port HTTPS. I want to make the distinction between them, the volume of that traffic, who is doing what, and more, if I can. Let's say, for instance, the performance degradation of an application. So how we do that? We do that through a layer 7 deep packet inspection engine, which is about the same than what we embed in the wireless controller. And we extract information like the application name, right? And the category on that application. In addition, we can also extract more information, like, for instance, the certificate, the expiration date of the certificate, the TLS version. By the way, you can identify a server that is out of compliance because of TLS running, the running version being TLS 1.0, for instance. You can identify those servers. We have extract also the SNI, which give you the URL of the web service being running. Everything is based on a flow table inside the ASIC, which is a hash table, right? We get back to this point. This is quite important for the scale. Those information are consumed by IPFix, which is a standard. So we are exporting to an IPFix collector. Application-based policy, this is a policy on which you will permit deny on application name and no longer on IP addresses. Traffic insight, which is an internal IPFix collector, and application-based GBP, so group-based policy that is used on VXLAN. We'll go on that. So you have a lot of choice. You can configure application recognition on physical port, and most importantly, on user role. So say that you are interested really to know about the traffic for IoT devices. So you set that up. But for privacy purpose, maybe you don't want to track what the employees are doing. So you don't configure that on the user role for employee. So very flexible. We support more than 4,500 applications into 22 categories. And these are the CX platforms supporting that for free. There is no license for application visibility. So as this is a pillar in our solution, let's dive a little bit more into all the CX engines for visibility, telemetry, and security into a switch. So let's understand what a switch is really about. So there is a fundamental component, which is the ASIC, a CPU, and inside the memory, we'll have an OpenView stateful database. You have interaction with the switch through CLI, REST API, Web UI, and so forth. So we already talked about the application visibility. It resides, most importantly, as a DPI engine on the core of the CPU. And we recently augmented that capability with a threat detection engine for TLS signature, based on proof point database, the same that is used on the mobility controller. So you see the homogeneity between what we embed on the switch and what is on the mobility controller. So we also have, on the hardware, a flow table. And that flow table, any new packet that is seen, any new flow that is seen, will be recorded on that flow table. If you configure IPFix on a port, we'll use another hardware table, which is called TCAM. Okay? And that would be augmented with application recognition with the application name on each flow. And we export that to an external collector. So it could be SolarWinds, for instance, any regular collector that you have. It's a standard base. We are exporting to that. But we also export the same data to what we call traffic insight. It's an internal collector, and see traffic insight like a flow telemetry API tool that you can exercise to extract data through API from the switch. So that is very much what we do on Central. We are subscribing to that API and get any flow that is inside the TCAM will be reported to Traffic Insight. So that's an aggregator. And it provides also information like client insight, like the DNS latency for your clients. So very, very useful for the health of the network. Finally, we've got application-based policy that is also using a TCAM to secure the traffic based on the application name. And we also use that for application-based GBP. So as we touch a lot of different blocks, you see TCAMs, flow table, let's dive a little bit more into the ASIC, right? So this is the very high-level view of blocks inside the ASICs. And the important aspect I would like to focus on is the ingress forwarding pipeline. And you see those blocks as well, hash table and TCAM. So let's dive a little bit more further. On the pipeline, we are parsing the packet, right? We are doing some lookup on the MAC addresses, on the IP, and more. We are checking if there is an access list, a policy-based routing, and stuff like that. So what's really matter for us, for the flexibility and the scale for the campus network switch? You've got TCAM, ingress TCAM, as you understood. You've got a flow table, which is inside the hash table, but there is more as well in terms of functions. And what really matters for us is the size of those memory blocks. Okay? That's really the important point. Because it immediately translates to the number of flows, for instance, we can support simultaneously on the switch. As well, how the TCAM is structured and granular enough in order to use multiple parallel lookups. What does it mean? It means that I want a VLAN access list, I want a port access list, I want a routed access list on an SVI, I want probably a policy-based routing as well, and all of that in parallel. So you need to make sure that the TCAM is flexible enough to run all those aspects in parallel. And finally, a flexible forwarding engine that use metadata in the packet that are not immediately the main field that you would think about, like the role of the user. That's a metadata we are going to use for the forwarding. And that's used for the policy. So to summarize all of that, I propose to go through that table. On the left, you've got the CX edge devices, and on the right, some kind of aggregator core devices or top of rack for the data center. And there are two main parts, the security, which is the enforcement, the policy, and the visibility, which is IPFix. So there are a lot of numbers. I'm going just to cover one line, which is the IPv4 access list you can get from that. So look at, for instance, the 6300 smart thread model. More than 65,000 rules you can write. Just to compare with a top of rack with a very famous ASIC from Merchant Silicon, that's 30 times more. For the visibility, let's take an example of the 5420 that William talked about. You can have up to 34,000 IPv6 flow simultaneously tracked on the box. So I hope that with that, you're convinced that our hardware is very much focusing on the visibility and the security. Let's dive a little bit now on more on the software side and how it simplifies the operation, how you get flexibility of architecture in the design for secure access. And I'm going to explain why we are moving to a role-based policy. On the left, you know very well that headache, maintaining IP addresses in access list. What we propose is to move to role-to-role class and role-to-role access list. Much easier. You will reduce the cost of operation, of the maintenance, and you will increase the security because as this is simpler, you will have more granular rules and you can really make security much efficient. So this is the role-to-role. On the left, you know that an access list keeps growing because you forget about why this access list was in place, turnover of people, merger, diversity, business partner integration. Everything leads to a large TCAM requirement for your switch and cost. So here, on the right side, assuming that you are doing client authentication, now you are going to use the role name instead of an IP address, right? So you are no longer dependent on those IP addresses, enabling highly scalable architecture. Think about IPv6 deployment. You are going to use role name instead of IPv6 addresses that usually consume 4 times IPv4 TCAM entries. And you can even further simplify the access list by using application recognition and putting application names instead of TCP port. So as you understand this, let's see how it happens on a deployment for wireless. For wireless, you deploy access points, controllers, you have tunnels to push the traffic to the wireless controller, but most importantly, you deploy a centralized policy manager, so ClearPass or central NAC. That gives you, with this architecture, a centralized enforcement of the policy. And you get all the benefit of layer 7 stateful firewall, IDS, IPS, reputation with WebCC, all of that inside the mobility controller. So you simplify the operation because now you introduce the user role that is given by the AAA server, the ClearPass server, and you are using role-to-role for securing the traffic. No VLAN to VLAN. So you are independent to VLAN, so much easier to provision VLANs as well, right? So the benefit for the wired client with this architecture, you enable poor access policy through the benefit of ClearPass. So what does it mean? It means that you are moving from a dedicated IP camera port, for instance, to a colorless port. So it means that you no longer need to provision your VLAN for that port. You provision the VLAN dynamically. So dynamic VLAN assignment, access list QoS on the connected endpoint. So just as a reference, in the CLI, you will have roles being defined, and you associate a VLAN to that role. Why not doing the same for the wired client? That's what we are proposing here, by using the same uniform policy for wired and wireless. So you do that by moving from a wireless controller to a mobility gateway. So it's just a name change. We call it mobility gateway now. And because we are ending GI tunnel overlay data plane from the switch to the mobility gateway. So we leverage exactly what I described previously, micro-segmentation for wired client. You can have multiple roles on the same VLAN, role-to-role, security policy. You have the same uniform policy across all the clients, wired or wireless, and you are independent of VLANs. Same benefit for layer 7 inspection. You can fingerprint some devices to exclude them to be pushed to UBT, to the mobility gateway. And you have a smooth migration, so you can say, for instance, those clients still do local switching, right, instead of being airpinned to the mobility gateway. But you would say, well, VXLAN, why VXLAN? What about VXLAN? I heard about GBP, so can you show me the difference between the architecture on the left, which is a centralized overlay architecture that I just explained, and an architecture which is fully distributed, where you've got VXLAN, VTEP, and everything is being enforced VTEP to VTEP. So which one to pick up? So let's dive a little bit more on the right side and have a traditional campus topology where you got those aggregation blocks. It could be buildings, floors, core, service layer on which you attach the mobility gateway, the firewall connectivity, or the WAN routing. And let's review a little bit the VXLAN terminology. So you have the VTEP, the VXLAN tunnel endpoint. You have, as well, VXLAN tunnels, two types, static. You don't need EVPN, or dynamic. You have MPBGP, EVPN, ALAS family to build those. So hence, we've got multiple VTEP types. The edge, what we call edge, is an access switch with EVPN control plane capability. Extended edge, no EVPN. You don't need to configure a BGP on that box. It's purely static VXLAN. A stub that is doing the aggregation for all the static VXLAN. It acts as an inter-VXLAN bridging between the static domain and the dynamic domain. The border, which do the handover to the external network. And the non-VTEP access. I would like to stress out this one. You can, for migration purpose, or smooth migration, because not all your current switch may be VTEP capable, you can cascade an access switch behind an edge and use the radius proxy function that William explained as a way to understand the client role that are connected behind the cascaded switches and still get the benefit of VXLAN policy on the edge. So very important for migration. So as you understand EVPN, well, you may say, well, I need to master BGP VPN. So we try to simplify that architecture by introducing what we call VS6 logical VTEP to simplify VXLAN dual homing solution. So on the right side, you have a standalone VTEP. Okay? It could be a standalone unit. It could be a VSF stack. It's one single CPU doing BGP control plane. On the left, it's a cluster of two. And that cluster of two, it's active-active for BGP speakers perspective. However, we simulate, we fake if it was a unique data plane. Okay? So it means that this, from the neighbor perspective, from that standalone VTEP, the other one is also a standalone VTEP. So let's see that into our topology that we were sharing before. So really the operational simplicity for you is that there is no concept of EVPN, Ethernet segment identifier that you will get into the multi-homing for BGP. There is an Anycast VTEP IP that is used, and thanks to that, you do not need to manipulate type 1 or type 4 EVPN routes. In terms of reliability, the two VS6 nodes are active-active. So it means that if you lose one from the remote VTEP, there is no change. It's the same next hop. There is no need of convergence. So it's extremely efficient, simple, and very mature for deployment. We still have the underlay CMP to reach the Anycast VTEP. And in terms of manageability and troubleshooting, you have less route to manage because thanks to the Anycast VTEP, you have only one route instead of two. And we are interoperable with MPBGP VPN for ESI in 10.16, and it's coming in phase for future releases as well. I understand now my VXLAN fabric, how I do attach the wireless traffic to my VXLAN fabric. Well, guess what? Static VXLAN. That's what we do between the mobility gateway and the stub. And just as a reminder, the need for that is that we need to transport the role, the source role of the client generating the traffic. So a way a mechanism to transport the source role is through the standard VXLAN header group policy ID. That group policy ID is nothing than the role. And you can see here in the switch configuration, you have role name associated to this ID. And the ID is transported in the VXLAN header. Hence, you have the source role for your traffic. So that's what we are using. The full picture is this one. You have static that I described between the wireless gateway and the stub. Then you have the dynamic fabric with EVPN VXLAN tunnels. Then you have the static VXLAN to the extended edge. And the role is transported this way. So for wireless user, it's static VXLAN, then EVPN. And for wired user, it will be either directly EVPN or static plus EVPN. And if you want to extend this capability behind the local campus, you can introduce Edge Connect SD1 and have VXLAN up to the stub to the Edge Connect, to the border to the Edge Connect. So then you can do site-to-site, role-to-role. So that's extremely efficient for us to transport the role. So you understand the transport of that role. Now, a little bit of homework. This is an example for healthcare for dynamic segmentation using group-based policy role. You need to define the role-to-role security rule between users. So you need to define all the roles. So this is a matrix, any to any. For instance, the IT admin has to talk to other IT admin, to doctor, nurse, monitoring. So you have rules, right? Those rules could be of permit any, deny all, or in between. It could be application-based. It could be reflexive policy. So you allow the ingress traffic and you allow the return traffic because of the flow was initiated by a trusted zone, for instance. And you have implicit deny between the roles. So you deploy your GPP policy and you authenticate your user through clear paths, like for instance the doctor, the monitoring system. And I take an example. Here this is the doctor on his tablet that want to print. So the wireless traffic will go to the mobility gateway, then go to the static VXLAN tunnels to the fabric, and then finally, based on the routing, will go up to the printer. And on the printer, this is where the traffic is enforced. So we do set the role at the ingress of the fabric and do the enforcement at the egress. So it's very, very efficient and extremely scalable. Another example where obviously an IP camera cannot communicate to a monitoring system. So you see, that's role-to-role as an example. So we dive into the left part, centralized overlay fabric. I explained the right. So on the left, you've got really operational simplicity, centralized firewall, layer 7 firewall, WebCC, a fair amount of DPI performance on that engine. Pay attention to some aspect like if you have a lot of east-west traffic, it might not be the right architecture, as well as multicast scale. On the right, we have a fully distributed switching and routing architecture with a lot of easy maintenance. You can turn down a VTEP, there is no impact on the others. Large multicast scale, lot of interoperability. It's standard-based. VXLAN is really a standard, and GPP as well. Role-to-role across sites is possible. Pay attention that you need to have some knowledge on EVPN, and you need to distribute the roles and to enforce the role-to-role policy. So thanks to Central, we are able to touch on those two aspects. So what I want to say is that it's not mutually exclusive. You can use both. And there is investment protection in the sense that you use the same CX hardware switch with the same software. You can do the left part. You can start with operational simplicity on the left and grow your network on the right side with more role-to-role. So as we understood the architecture, I want to touch base a little bit more on why our switch act as AI-ready networking sensor. So really something that we were focusing this morning with Sudhir and Bob is that you really do care about the quality of the data for machine learning, right? So anything you cannot measure, you will not improve, that's for sure. So let's review the telemetry sources that you get and the quality of that. On the left, it's legacy. You all know about SNMP, syslog, SFlow, which is a sampling technique. And you move from that to more modern techniques like IPFix, which is really tracking any single packet on the network, right? I insist on that. Traffic insight that I will insist on, client insight, inbound flow analyzer, IPSLA, network analytics engine. So there is a lot of data in that table that you will get. I just don't get into the details on that, just two things. REST API. All the CX features are API native. Okay? It means that we can subscribe to message bus. And on traffic insight and client insight, this is exactly what we do. Remember, traffic insight is an internal IPFix collector. So it means that all the flows that comes into the switch is seen on, thanks to IPFix, on traffic insight. Central is subscribing to the message bus of traffic insight. It's highly scalable. You don't need to poll every 5 seconds every switch on your network. It's dynamically uploaded to Central. Client insight is very much useful to understand the quality of the network for the client. It will measure the authentication latency, how much time and how fast the radius is authenticating the user. The latency to get an IP address through the HTTP. The latency to the DNS server. The latency to the ARP, for the ARPing to the layer 3 default gateway. All of that is being tracked with client insight. So you get the view. In addition, with IPFix, information element, we augmented that with application visibility. So there is a lot of criteria that we have. I just want to focus on the two last. This is the handshake between the client and the server. So thanks to the record of TCP establishment time, what we get from an operator, we get the following. And 20 years back, I really would like to get that. Here, Salesforce.com, I'm going to just look at that. I can click on that, see the performance tab, and immediately see the latency that I have between the client and the server. So I can analyze and proactively anticipate issues that you've got to reach some applications, like Salesforce.com. So that's the outcome on Central. This is available for wireless. For wired, it will be available next quarter, next year. So the DHCP latency issues. So this is all the AI-assisted resolution that you saw this morning. It's here just another example. Something for mean time to innocence. You know very well the DHCP issues and load that you can have on DHCP server. You all experience that. So this is, with one click, you'll get the alarms on the DHCP latency thanks to Client Insight that I just explained. Another one, abnormal download from an IoT device. That's a peak of traffic that is really abnormal from a baseline that you monitor for the last 30 days, for instance. Suddenly, you have a peak of traffic. Well, that's not something that it should happen. Next, suspicious protocol, for instance. Why I do have an IoT device sending FTP on port 10 on a China website. Okay, so suspicious protocol will be based, again, because we are tracking every flow from every device. Think about the quality of the data. One latency issues, I touch base on that. You've got high peak for the latency. I can click on that and immediately have the list of all the applications that are suffering from, let's say, an ISP circuits that maybe have some latency issue. Next is about optimizing a policy. Maybe it's not obvious to know exactly what an IoT device is doing, right? So here, simply, we track every flow from every IoT device. Hence, we can, after sometimes, propose rules that you can set up for that particular IoT device. Here, it's a scanner. So with internal IP addresses or external IP addresses. So I want to show that being real. So I don't know if Matt Billy is in the audience today. Yes, thank you, Matt. Maybe you can stand up, because I really want to thank you for all the details that you gave to us. So this is a case study from Kili University. Their vision was really to create a smart campus environment with modern learning techniques. So the focus was really on the user and the application being used. And so obviously they have to construct a robust connectivity across a large campus, and the campus is really large, you can see, and it's more than 700 switches, more than 2,500 students. And it's not only campus, but data center as well. Everything was built on CX switches. And the key driver for them was, well, same operating system from the edge campus to the data center. ClearPass was existing already for the legacy network. So it was a key accelerator for them to create what? Guess what? The colorless port, so that you can now accelerate the deployment of your roles. Colorless port was fundamental for them. UBT, very easy to manage and operate, and flexibility of saying this role I'm going to push to the controller or not, or stay local. Currently, they are using 4 tenants, 50 user role or roles per tenant. They are using a lot downloadable user role that is configured on the ClearPass. And they are pushing to UBT everything about that they don't know IoT visitors. So you have the platform of choice, and the future for them is really to expand more with our capability like application-based policy, looking at the CX 10,000 for east-west traffic in the data center, as well as the transition to New Central. So this is the global networking overview. So that's very nice to see a lot of equipment, network equipment live, and the view of the application that they've got on their network. So that's a good story. So if you have questions, maybe we can meet with Matt after the session. So to conclude, I hope that you are convinced about the interest of the role-to-role policy, right? But how I do assign a role on an IoT device and how secure it is. So this is from IDC, one of the top priority for AIOps topics. So the profiling of the device. So let's dive a little bit to a demo. So this is a recorded demo. So I've got a Netatmo camera, the brand is Netatmo, that I'm plugging into the network without doing anything. So this is the MAC address 6106. So I want to see how Central look at that from a client classification perspective without doing nothing, right? So I'm going to click on classification. That is on the right side here, and you see it's a tag IoT. The tag IoT has been done automatically, smart home. So that's without doing nothing. And then you've got you click on application, you've got the application of that camera. Now I want to create a custom tag for me. So I want to create that custom tag with some applications that are related to that tag. So it means that if I see those applications for that MAC address, I will tag that MAC address with a specific tag that I create. This is the Netatmo camera tag. And you see on the conditions below, I'm putting some application name. So it means that if those applications are seen, Central will flag that MAC with this tag. You will see the benefit of that. So now I'm going to create a role. The role will be IP camera role. Okay? That role, I will assign a VLAN for that role. So let's say VLAN 110. And I will also create a policy, an authorization policy in Central NAC. So this is back to the menu, Central NAC. I'm going to configure an authorization policy, and that authorization policy will say, hey, if I see this tag, I'm going to assign this role. Okay? So here, Netatmo camera tag for wired device. I'm going to assign below here the IP camera role. Let's see that in action. So I unplug my camera. So this is on port 1. I plug it back, and after a while, I can click on client, and you will see the tag, Netatmo camera, the role, IP camera, and the VLAN, 110. Okay? Good. So this is the dynamic assignment based on application. Now, is it secured? I want to spoof the MAC address of the IP camera with my PC and check. So for that, I'm going to create another tag, which is called spoof IoT. So spoof IoT tag is what? In the attributes, everything that is IoT, smart home, lightning system, and application Windows Update. You see? Nothing about Windows Update for an IoT device. So then, now, I assign a new role, which is about quarantine. So I call it isolation. So that role isolation is when I see this tag spoof IoT. Okay? And I will assign the role isolation when I see the applications that are related to Windows Update for an IoT device that should definitely not do Windows Update. Okay? So this is the condition, spoof IoT, and I will assign the isolation role. So let's see that in action, and that would be the conclusion of the session. So I'm plugging the camera, the PC, okay? So as you can see, the PC, I fake the MAC address 6106, and that PC will initiate Windows Update. after a while. So right now, it's a bit long. It's about 10, 15 minutes. So we are going to reduce that time. Here we go. You see, there is a spoof IoT tag now on it. Isolation as a whole, and the VLAN is not the VLAN that we used previously, 666. So I hope this is convincing demonstration to you. Please join the community. Thank you very much, and we appreciate as well your feedback. Thank you.